All right, so here we're going to check out section 3.5, 6, and 7. So they kind of all go together because basically what we're going to do is we're going to dissect this idea of linear, right? We've been talking about linear here already, but we're really going to dive deeper into it. Okay. So imagine, the usual stuff that we've seen before. If I give you this chart here, can we find some sort of pattern to it? Okay. And then eventually I want to find the equation that models this chart, simplify as much as possible, and then kind of plot to see what's going on. Okay. So you can kind of see you got the points 1, 1, 2, 3, 3, 5, 4, 7. You can even plot those, which we'll get there in a minute. But hopefully you can see it's that usual. See 1, 3, 5, 7. Oh, look, the outputs are going up by 2. You're definitely adding 2, right? That's that usual arithmetic sequence that we talked about before, right? So the equation, you can do the same thing we did before, right? It's starting with 1. Then what do we do? Well, we keep adding 2, right? So we're going to add 2 over and over and over again. But what is that repeated addition going to turn into? It's going to turn into a multiplication. And we can use that little trick of subtracting 1, just like we did before, right? Because since we're starting with 1. All right. So nothing crazy new here, right? But now we can simplify this, right? This is the same as, again, don't add these. So like terms, you got to distribute the 2 first, right? So this would be 2x minus 2. Now when you combine your like terms, the 2x is just sitting there because it's not like anyone, but the 1 minus 2 would be negative 1, right? So that's as simple as it's going to get, okay? It is a check, right? If you plugged in 1 for x, 2 times 1 is 2, minus 1 indeed is 1. If you plugged in 2, 2 times 2 is 4, minus 1 is 3. Plug in 3, 6 minus 1 is 5. Plug in 4 is 8, minus 1, 7. See, it's working, okay? All right, but how does that work over here with the graph, okay? Well, if I looked at the point 1, 1, then you got the point 2, 3, right? Then you got the point 3, 5, and then you got the point 4, 7, and then that's it, okay? Now here's the thing. All of these points line up, right? They're making a nice, perfect line, just like before. They're not just kind of random all over the place. They are making a nice, perfect line. So what is it that's making it a line? What's causing these points to line up and not just be random, okay? It's because you keep adding the same number, okay? And so kind of the idea here is what you can do. Like, I think it's easier to see the pattern, right? See the pattern in the graph, right? Because see, look, you're going up 2, right 1. You're going up 2, right 1. You're going up 2, right 1. You could even continue that, right? You could go up 2, right 1, right? And that's kind of like what was happening here. If this were to continue, 1, 2, 3, 4, if this were to continue, this should be 5. Then these are going up by 2. So 5, 7, this should indeed be 9, right? And that's what they're talking about here. See how it says use the graph to predict the value of y when x is 5? So when x is 5, sure enough, look, it's up here at height 9, right? So pattern-wise, 1, 2, 3, 4, 5, this should be going up by 2. We'd expect 9. Pattern-wise in the picture, if this were to keep going, this should be up here at a height of 9, okay? But you can also use the equation, predict the value of y when x equals 5, right? So if you were to do y equals 2 times 5 minus 1, just plugging 5 into the equation, you're going to get 10 minus 1, which again is 9, okay? So the point here is kind of what you want to do is seeing how all three of these relate. Bunch of points. This is the equation, which just describes how those points are related with an equation. And then the graph shows a picture of all of these points, or it shows how all the points that satisfy the equation look, okay? Now, you could keep going with this. So like 1, 2, 3, 4, 5. Then the next one would be 6. And then we'd expect going up by 2, 7. This would be 11. So over here at 6, we would expect it to be up here at height 11. It's just that it's off the grid, right? But it's up there, okay? But you could even keep going backwards. So think of it as see down here. See, you are adding 2. So if you were to go backwards, instead of adding 2, you'd be subtracting 2. So back here at 0, at -1, at -2, at -3, at -4. Like if we were to count backwards, we should be subtracting 2. 1 minus 2 would be -1. Subtract 2 would be -3. Subtract 2 would be -5. Subtract 2 would be -7. Subtract 2 would be -9. But again, you can kind of see that in these points here. Like see if I were to go back 1 here, see we went down 2. Oh, there's 0, -1. Then you'd go down 2, left 1, there's the -3. Down 2, left 1, there's the -5. Down 2, left 1, there's -7. Down 2, left 1, there's -9, right? So you can see how that pattern continues, which would then create a nice, perfect line, okay? Again, these are all nice points, right? There's all kinds of points in between, right? There's all kinds of numbers between 0 and 1. So here's 0, -1, and here's the point 1, 1, right? There's all kinds of points in between here, just like there's all kind in between, in between, in between. It's just that we're using the nice ones on the grid to generalize what all of them look like forever. Okay. But hopefully, again, you can see if you're going one direction, you're adding to the other direction, you're subtracting to. Or you can see that slope idea, right? You can see the up 2 rise, or the rise of 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Okay. You don't have to, but again, you can hopefully see, like if I looked at this point and this one here, so you went up a bunch to go over. But see, you went up 1, 2, 3, 4, but then you went to the right 2. But again, what's 4 divided by 2? Still 2. It's the same slope, right? If I pick this point and this one here, right, you'd have to go up a whole lot and go over a whole lot, right? Rise is huge. The run is huge. But when you divide, guess what you're going to get? 2 every single time, right? So what makes a line? The same slope over and over again, okay? But again, we want to also see the difference or the relationship between the grid here, with the points on the equation and then the actual graph, okay? So like it wants you to use the graph to predict the value of y when x equals -3. Okay, so if I continue this line down here, when x equals -3, that's down here at -7. So when x is -3, the graph looks like it wants to be at a height of -7. How would I do it when you have the equation? Oh, the equation, you just plug it in, right? So it'll be y equals 2 times -3, subtract 1, right? But 2 times -3 is -6, and then subtract 1, sure enough, -7, right? But you can also see it from the numbers, right? If you kept going back until I get to -3, look, it's also -7. So again, whether it's from the chart, whether it's from the equation or from the picture, they're all going to be the same. Okay. Now, what happens if you had a not so pretty number here? All right. So when x is 2.1, well, where is 2.1? Here's when x is 1, x is 2, x is 3. So 2.1 would be somewhere in here. Okay. It's between 2 and 3, which means the output, we don't know what it is, but it's definitely probably going to be between 3 and 5. Right. You can also kind of see that from the grid here. Right. 2.1. So here's 2, here's 3. So 2.1 would be somewhere in there, right? Closer to 2 than 3. So if you went up to the graph, it's over here. So we're looking at somewhere in here, but it's not obvious what it is, right? Since this is not a nice number, right? It looks like it's between 3 and 5. And this one also looks like it's between 3 and 5. But neither one of these are going to give me exactly what it is. This one will. That's the beauty of the equation. So even when you have a nasty number here, you can still plug in 2.1, right? So like, I guess what I'm trying to get to is like the graph here. Is it obvious what it is when 2.1? No, it looks like it's around this area. So it's around 4, right? But I don't know. It's not obvious is the point. Okay. But if you plug it into the equation, 2 times 2.1 would be 4.2, right? 2 times 2 is 4. 2 times 1 is 2, so it's 4.2. But then subtract 1. Oh, it's actually down here at 3.2, right? So 2.1 is actually down here at 3.1. So it's a little bit below 4, right? Again, it's chart-wise, 2.1 between 2 and 3, not obvious, but it's between 3 and 5, okay? Looking at the picture, not obvious, but it's around 4. The equation, it is obvious. It's going to be exactly 3.2, right? So that's, the chart is when you're going by nice numbers. The picture, you can kind of rough idea of where it should be, right? But the equation will always work. That's the beauty of it, right? Okay. Now, so that number that we keep adding over and over again is the slope, right? That's called the number here. That's with the x. That's the slope, right? That's the 2. But another thing we need to talk about is this idea of what's called a y-intercept, right? So I want to state the slope and the y-intercept, but what is the y-intercept? So the y-intercept is where the graph hits the x-axis, okay? It hits the x-axis right there at 0, -1, okay? That's your y-intercept, okay? So when x is 0, whatever the y value is, that's where the graph intercepts the y-axis, okay? But the whole idea here is if you look at your equation here, see this is y equals 2. Oh, that's my slope. And if x was 0, look what the y is, -1, right? So let me write this down here. So basically, after you set up your equation and simplify it, it turns out the number that's with the x, this is the slope, and the number that doesn't have the x, right? If x were 0, like if that were to go away, what's left is going to give you your y-intercept. Okay. So you guys may have seen this before. I don't know. I haven't even talked about it already in here, but that's what leads us to this crazy form that everybody, or not everybody, but a lot of people memorize, right? This y equals mx plus b. You may have seen this before, right? Don't get lost with the notation. This is what you want to think. It's y equals blah x plus blah. So there's going to be some number with the x, and there's going to be some number without the x. The number with the x is your slope. The number without the x is your y-intercept. So again, think of it as this is the number you're starting with. That's your intercept. And then you're going to keep adding the same number over and over and over again. That's the slope. That repeated addition is what causes you to multiply by x, right? Okay. But the point is now we can speed up this process. Okay. So if I give you an equation, I want to be able to state the slope, the y-intercept, and then use that to graph it. Okay. So when you see y equals 3x plus 1, what you want to do is look for the x. Whatever number is with the x, meaning multiplied by x, that multiplication, that's the thing that you keep adding, right? Repeatedly adding the same thing over and over again. That's why the slope is 3. And the y-intercept is where you're starting. In other words, if x were 0, if it were not there, we're talking about the 0.01, right? If you just wrote 1, is that okay? Sure, you're all right. But technically, the y-intercept is a point. You need two numbers, the x and a y. And I think it's really helpful to see that so that you know when x is 0, you're talking about the y coordinate, right? Because when you go to graph this, when x is 0, when you don't go left to right, you're going to go up 1, right? It's easier to see that point. Okay. Now, what does a slope of 3 mean? A slope of 3 means you're going to go up 3, right 1, right? It's kind of what we're doing before, right? You always want to think of slope as a fraction. If it's positive, go up. If it's negative, go down, and then always go to the right until you're really good at what you're doing. So I have a starting point here. That's my y-intercept. So from here, you can go up 1, 2, helps if I can count 1, 2, 3, and then go right 1. And then you can keep doing that. You can go up 1, 2, 3, right 1. Okay. But just like we were talking about in that chart deal, if you keep increasing, see how you're adding? If you go backwards, you'd then be subtracting. So you could go back to your y-intercept and go down 1, 2, 3, left 1. Down 1, 2, 3, left 1. Down 1, 2, 3, left 1. But you see what it does? It creates a bunch of points that are perfectly in line so that now we can connect them. Make sure that you connect them. That is the whole point. We are trying to graph the whole line, right? So we're after all of these points. It's just that we're using these nice ones to help guide all the ones in the middle, right? All right. What about this here? Again, don't get lost. It's not just the very first number that you see is the slope. Don't do that. Look for the x. Okay, there's my x. What number times x is negative 3? That's the number that's causing the change. That's the number you keep adding, or in this case, subtracting. But where are you starting? You're starting with, if x were not there, 4. Or technically, you're starting with the 0.04. So if you went over here to the graph, you're talking about the 0.04. Again, the slope, you probably always want to think of it as a fraction. So you might want to think of this as negative 3 over 1. So since it's negative, you're going to go down 1, 2, 3, right 1. And then keep doing that. You can go down 1, 2, 3, right 1, down 1, 2, 3, right 1, down 1, 2, 3, right 1. Right? You can even go back to here, but instead of going down and to the right, you could go up 1, 2, 3, and then go back left. And then you'd be off the grid. But so now we filled up as much of the grid as we can with a bunch of points that we could now connect. And there's your actual line. I know everybody sees a fraction and they panic. Oh, it's actually not bad. Okay, it actually makes things easier, believe it or not. So when you see this, look for the x. Okay, your brain should go to the x first. Oh, what numbers times x? 2/3. And then what numbers without the x? In other words, if x was gone, you have the 0.0, negative 4, right? If x was 0, y would be negative 4. Okay. So what does that mean? You would start at 0, negative 4, right? That's your y-intercept. That's where you'd start at. And the slope is 2. It's positive, so you're going to go up 2, right 3. right? Go up 1, 2, right, 1, 2, 3. And you can keep doing that. Up 1, 2, right, 1, 2, 3. Up 1, 2, 1, 2, 3. Off the grid, but at least you got the idea. And again, you can keep doing that, and you can even go back. Now, instead of going up and to the right, we can go now down and to the left, right? So down 1, 2, left 1, 2, 3. Down 1, 2, left 1, 2, 3. Right? And look at that. We got a bunch of points that line up perfectly. Then we can go in and connect them. And there's my actual line. Right? All right. A couple more examples here. Again, when you see an equation like this, the first thing you should do is, oh, there's my x. Okay, so what's with the x is this crazy number here. Now, it happens to be a decimal, but so what? So this is negative 0.75. That's the number that's times x. That's what's causing the change. If x were not there, in other words, when x is 0, you'd have a 5. So we're starting with the 0.05. Right? Okay, so you go to the graph. Here's 0.5. All right, now here's the hard part. Negative 0.75. Ugh, what does that mean? Negative 0.75 means negative 0.75 over 1, which means you're going to go down only a little bit just to go right 1. But how do I go down 0.75, right? That's a little crazier. What you might want to do is get it to a fraction, okay? So think of it as, how can I get 0.75 as a fraction? See, my point here is, I know most people like decimals, but fractions are better when you're doing slope, right? So what is 0.75 in fraction form? Well, you could think of it as, 0.75, there's kind of like, you're taking a whole 100% and you're really breaking into 4 pieces, right? That's 25. But if you had 3 of those, you'd have 75, right? So 0.75, that's really the same as 3/4, right? Because you're broken into 4 quarters. You keep 3 of them, you get 0.75, right? So anyway, the point here is this would be the same as negative 3/4. Okay. That's why it's a lot easier to count here. So from this dot, it's a lot easier to count down 1, 2, 3, right? 1, 2, 3, 4. Right? And then you keep going down 1, 2, 3, go right, 1, 2, 3, 4. So we even go back to the y-intercept and go up 1, 2, 3, left 1, 2, 3, 4. Right? It's kind of hard to see that, but like imagine, and let me zoom in here really far. It still would work. Hold on. So remember, it was negative 0.75. So what that's saying is you would have to go down only part of 1 by 0.75. They got to take a guess. It's like roughly somewhere in there to go right 1, right, which would be in here. But the point is that would still line up, though. Hold on, let me connect these. Hold on. Right, so when you connect those, see when I went down 3 and right 4 got you to here, you can do it, but it's really hard to do because it's like negative 0.75 over 1. Then you'd have to go down 0.75 over 1, right? Then you have to go down 0.75 over 1, down 0.75 over 1. So it gets you there, but who wants to count a bunch of 0.75s, right? That's why fractions are actually better than decimals when you're doing the slope idea, right? Okay, what about this one? Okay, well, look, there's my x, so the slope is 2/3. Great. What's the y-intercept? There's no other number here, right? So what you might want to do is think of that as 0, right? Or in other words, if x is 0, see, everything would disappear. So you would be left with 0. So that means you really are starting at the point 0, 0, or you're indeed starting at the origin, right? So if there is no other number being tacked on, being added or subtracted in front or back, whatever, think 0, 0. Okay. But the slope is 2/3. So again, from there you go up 2, right 3. Whoops. And go up 1, 2, right 1, 2, 3. Up 1, 2, right 1, 2, 3. You can even go back and go down 2, left 3. Down 2, left 3. Down 2, left 3. Right? But again, they all line up. Then you can go in and connect them. And there's your line. Okay. Last one like this. Again, look for the x. Now, wait a minute. It doesn't look like there's a number that's times x, right? See, this -5 is being added, so that's like your y-intercept. So 0, -5 is where you're starting over here, right? But the slope, remember, is the number that's times x. But remember, when you don't see a number with the x, that's an implied 1, right? Same thing we were doing before, like when you're adding like terms. If you don't see anything in front of the x, it's implied to be a 1. But again, we probably want to think of that as a fraction, so it's like 1 over 1. right? So you're really starting at 0, -5, and then the slope is up 1, right 1. So you're going up 1, right 1, and you're just going to follow basically perfectly along that grid, up 1, right 1. And you can even go back, right? Which again, they're all going to line up, connect them. There we go. Right? Okay. So if you're given the equation, you should be able to read off the slope, read off the y-intercept, and then graph it. All right. What if I wanted to go the other way? Now you're given the graph and you want to read off the slope, read off the y-intercept, and then come up with the equation, right? It's the exact opposite. Okay. So if I'm given this first one here, I think the easiest thing to do is there's the y-intercept. Not that I don't care about the x-intercept. Don't do that. We're looking for the y-intercept. So where does it hit the y-axis? Oh, that hits at 0, 1. Okay. Then we can do like we did before. You can just follow the grid and all the nice points. The ones that are on the grid, like, no, 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 no. Oh, that's a nice one. No, no, no. Oh, that's a nice one. No, no, no. That's a nice one. No, no, no. Yes. No, no, no. Yes. Right? So these points here are on the grid nicely. You can pick any two you want and calculate the slope, right? Like see how it's up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2, right? You keep going up 1 and right 2. Okay. Heck, you can even went from here. Like if I went up 1, 2 and over 1, 2, 3, 4, you're still going to get 2 over 4, but that's still 1/2. So the slope is still going to be 1/2. So then the equation, think y equals blank x plus blank. The number with the x is the slope, so that's going to be your 1/2. And the number without the y-intercept, 0, comma that 1, there's your 1, right? So it's like y equals 1/2 x plus 1. And there you go. You certainly don't have to, but check this out. One thing you could do as a check, right? I mean, look at this point right here. This, see when x is 4, you're up here at height 3, right? So this is the point 4, 3. So as a check, what this is saying, if this worked, when x is 4, y better be 3, right? So you could check it, plug in 4, and see what happens, right? Well, half of 4 is 2, plus 1 is indeed 3. It's working, right? You could follow it along. You could pick in this point, right? If you plug in -4, you better get -1 out. If you plugged in -2, you better get 0 out, right? If you plugged in 2, you better get 2 out. It's up to you if you want to check it, but it couldn't hurt. All right. What about this one? All right. Well, it's hitting the y-axis right there. We should start that. So that's the point 0, -2. Okay. Follow that along. There's a point. You could even go back if you wanted, whatever. But what are we doing? Oh, look, we're going up 1, right? 1, 2, 3. Up 1, 1, 2, 3. So the slope is 1/3, right? Up 1, right 3. So then your equation is going to be 1/3. That's the number with the x. And the -2 is the one without. So y equals 1/3 x minus 2. All right. Same thing here. Oh, it's hitting the y-axis up here. Let's start with that. There's the point 0, 3. If we follow that along, this is no. I got all the way down to here, and then no, off the grid, and then, so actually, those are the only 2 points on that are very nice. Right, the rest of them aren't nice, so you kind of have to use these two. If you're going down 1, 2, 3, 4, and you're going over 1, 2, 3, right? So if you're going down 4, right 3. Also, it's a good point to make. See both these lines? See how they're going up? Positive slope. This one's going down. Better be a negative slope. So -4/3. So y equals -4/3 x plus 3, right? The slope is with the x. The y-intercept there without the x. And there you go. All right. So we got to be able to do it from the graph, got to be able to do it from the equation, see how these things work. Okay. But now we want to be able to use these in some sort of application. Okay. So let's check this out. You've probably seen this before, maybe not with quite such a heavy discount, but let's suppose your local gas station offers a 30-cent gallon discount for buying a car wash, right? The current advertised gas price is $3.85, and car wash costs $8. Okay. So what this is saying is basically $3.85 per gallon. Okay. But if you buy an $8 car wash, they're willing to give you 30 cents off per gallon, right? So the ultimate question here is the total cost ever lower even with the car wash? So if you were to buy the car wash, would you end up paying less money than if you didn't buy the car wash? Well, let's check it out. So one thing you could do is kind of like what we were doing at the very beginning here, right? We want to see how do the numbers work with the equation and then work with the graph. We want to see how all three of these things relate. This is just an actual example. Okay, so let's check out different examples. So like these are different gallons of gas. How much would it cost me? Well, the cost of gas with no car wash. So basically this is silly, but you didn't buy anything, right? So no car wash, didn't buy any gas, so it's not going to cost me anything at all. But let's say, again, no car wash, but I bought 5 gallons, okay? So that means you're going to do $3.85 for the first gallon, plus $3.85 for the second one, plus $3.85 for the third one, plus $3.85 for the fourth one, plus $3.85 for the fifth one. Hopefully you're seeing this is silly because, look, you keep adding the same number over and over again. What does that mean? That's your slope, right? The $3.85 you could have just multiplied by 5, right? Because you did it 5 times. So 5 gallons is going to cost me $19.25. Right? If I bought 13 gallons, it would be $3.85 times 13, right? So $50.05. 20 gallons, 20 of those, 77. And then 30 gallons, $115.50. All right. Now, over here, cost with the car wash. Now, this you got to pay attention because now if you don't buy any gas, you still have to pay the car wash, which is $8. Okay. But now I'm buying 5 gallons. But wait a minute, we're not paying $3.85 anymore. Remember, you are paying $3.55 now. Because look, it's $3.85, but you're getting a 30-cent discount, right? 30-cent discount. So you're really only paying $3.55 per gallon. Okay. So it's really now $3.55 times 5, and then tack on the 8 for the car wash. Right. So it's really $3.55 times 5. There's my gas. Plus the $8 car wash. So $25.75. Okay. Now 13 gallons. Okay. Let's see if we can do it all at once. So you're doing $3.85. No, discount, $3.55. You're going to do that 13 times plus the $8 car wash. So now it's $54.15. Then the next one was 20, right? So you can shortcut, you just go up here and change that 13 to a 20, right? But see, that's the point, kind of getting used to it. Hey, it's just $3.55 times the gallons plus 8. So 79. And then the same thing with 30 gallons. So 30 of those $3.55 plus the $8 car wash is now $114.5. All right. So is the total cost ever lower even with the car wash? Well, if I did 0 gallons, no, it's more expensive. 5 gallons, still more expensive. 13 gallons, more expensive. 20 gallons, still more expensive. 30, look at that. 30 gallons is now cheaper if you actually bought the car wash, right? So basically, getting enough gallons here, basically the point here is if you buy enough gallons, it's worth buying the car wash to get that discount, okay? So is the total cost ever lower based upon these numbers that we picked? Yes, 30. But notice what's happening here. See, like the space here is 8. Now this is like 19, 25, 50 and 54, 70. See, they're getting closer. So basically what's happening is these are getting closer, right? These are bigger here, but they're closer, and all of a sudden it switches. So somewhere between 20 and 30. That's the first time that it would happen. Somewhere between 20 and 30, these two would have to be equal, right? And then eventually this one would be better. So let me show you. It'll make more sense when we look at the picture. All right, so first off, can we create a linear equation? Well, this first one here, right? Remember you kept adding 385? That was your 385x, right? That's your slope, basically. You kept adding 385. You don't have to write it, but you can think of it as your y-intercept is 0 because you didn't pay anything, right? That's your mx plus b. So 385 was the number you kept doing per gallon, plus the initial 0 in this case. But this one, the slope was 355 per gallon, but there was an initial or y-intercept of 8. right? So you were starting with 8, and then you kept adding 355 a bunch of times. Okay. But roughly, what would that look like over here? So think about car wash. If you were to graph this, see the y-intercept would be 0, but the slope is 385. So that means you're going to go up 385 to go over 1, up 385 to go over 1, up 385 to go over 1. You would keep doing that, right? And that eventually is going to create this line. Okay, so this would be without. But this one started at 8, which means do a different color. So this is going to start here, right? So it's going to start much higher at up at 8. But 355. But the point here is 355 is less than 385. So if this one went up 385 to go over 1, this one's going to only go up 355 to go over 1, right? It's only going to go up 355 to go over 1, which means it's not going to be as steep. So when you connect them, it's going to be like that. And so this one is with the car wash, right? But see, that's kind of the point here, right? So 0 and 8, this one starts at 0. This one starts way up here at 8. But this one has a higher slope than this one. That's why it's steeper. Whereas this one has a lower slope. That's why it's not as steep. It's not going up as fast, right? 385 versus 355. Okay. But the point here is there's got to be some magic number here where what happens, they're exactly the same. Because see, look, if you below this, right, it's cheaper to go without. But as soon as I pass that number, now the width is going to be cheaper. Okay, so that's the point. Where is that number? Based upon our numbers we have, it's probably going to be between 20 and 30, right? Because see, I mean, like once I 20, right? See, this one's still more expensive, but I got the 30, now it's cheaper. So somewhere between 20 and 30. But how can I figure out where that is? Well, I have an expression, 385x. That's how much gas is going to, or how much it's going to cost me in total for the car wash. Or sorry, without the car wash. But then the 355x plus 8, that's how much it's going to cost me with the car wash. What do I want to have happen? I want them to hit each other. I want them to be the same. I want them to be equal. Oh, so now we have that skill of solving an equation. All right. So how do I solve this equation? Oh, I got x's on both sides. Move one over by subtracting the 355x. You could do the other way too, but just, because there's only an x here. Like, so basically I want the x's to come together, and this is non-x, so I'll leave that alone. Right? So the 385x minus 355x turns out to be that 0.30x, and then this would equal 8. And then to get the x by itself, we can divide by that 0.30. Right? So then x would be whatever 8 divided by 0.3 is. 26.6 repeated. All right. So what makes you understand what happened here? 26.6 gallons. Right there, if you were to buy exactly 26.66666 gallons, which one would be more expensive? Neither one. They would be exactly the same price. That's the point. If you were to buy that exact same amount, that each one would be the exact same. And the whole idea here is if you're below that, don't buy the car wash. If you're above that, buy the car wash, right? So is the total cost ever lower with the car wash? Yes. Anything above 26.6 gallons, right? So as long as you can buy or can afford, or at least your tank is big enough to hold this, if you bought any more than this, it's actually worth it to buy the car. If you don't even care about the car wash, you can buy the car wash, throw the ticket away, don't care. But it would be worth paying that extra $8 just to get that discount, as long as you bought more than that. Anything less than that, then it wouldn't be worth buying the car wash, unless you really wanted the car wash anyway, right? But that kind of builds that idea of basically what we want to do is no matter what is given to us, we want to be able to come up with an equation that will work. Okay. So I want to find the equation of a line that best fits whatever conditions are given to you. Okay. Just remember y equals mx plus b, right? That's your best friend. You want to keep that off in your corner, right? So y equals blank x plus blank. The two things that I need are the slope, and this is 0, whatever. Okay, whatever that is, that's what goes here. If you know these two things, you got your equation. Okay, all right. So let's say I told you I want to come up with the equation line where the slope is 8 and goes through this point 0, 2. Well, basically, they told me the slope was 8 and it goes through the point 0, 2. Oh, so that's got to be the y-intercept. So it's got to be y equals 8x plus 2. There's more to that. I mean, that's it. But let me explain more to that. Like, because the next one here, you say, oh, look, m is -2 and goes through this point. You might be thinking, oh, then the slope is -2. And then since this is a 7, you'd put a 7 there. No. Hold on. This one's different. I mean, it's worth writing that just to show you. The difference between this is actually the y-intercept. See how it says 0, comma, whatever? All right, so when x is 0, they told me what the y-intercept was. That's why this works. But here, that's not the y-intercept. Okay, so did they give me the slope? Yes. Did they give me the y-intercept? No. See, like here, they gave me the slope. They gave me the y-intercept. Easy. Gave me the slope. Oops, they didn't give me the y-intercept. So you could figure it out. Okay. One thing you could do is if you think about this graphically, the point 1, 1, 2, 3, 4, 5, 6, 7 is here. Okay. Right. But what is the slope? Slope is -2. That means you'd have to go down 2, right 1, down 2, right 1, which means it would eventually look like this. But I don't want that. I want over here. So you'd have to go back by going up 2, right 1. But if this was at 7 and you went up 2, this would have to have been at 9. So indeed, it would have hit the graph or the x-axis at 9. Since it hits at 9, and that's basically telling you your b is 9, so the equation would then be -2x plus 9. Right? So one way to do that is take the point that they're giving you that's not the y-intercept and apply the slope to like get back to the y-intercept. Or, if you don't like that idea, think of it as we know it's y equals, I know the slope is -2, so it's going to be -2x plus blah. They didn't tell me what it is, okay? But this is saying when x is 1, y better be 7, right? So if I plug in 1 for x, we are going to try to figure out what is this magic number here so that I do indeed get 7 out for y, right? When x is 1, y better be 7. Oh, so -2 times 1, this is -2 plus b. Oh, so -2 plus what number would get me to 7? Oh, to solve this equation, you'd have to add 2. Sure enough, there's your 9, and that leads me back to there. Right? So whether you want to do it from the picture or whether you want to do it from the equation, it's up to you. But basically, it's just like a big puzzle. You just got to take what's given and figure out the slope and the y-intercept. Okay, so let's check this out. Let's say it goes through the point 2, -5, and 5, 1. Did they give me the slope? No. Did they give me the y-intercept? No. So we got to figure out both of them. Okay, so we can do like we did before. We need to find the slope, which is the rise and the run. So remember, the rise is going from one y-coordinate to the other. So the rise, in this case, went from -5 to 1. Think negative world, positive world. So you had to go up 5 just to get to 0, and then 1 more to get to 1. So you went up 6. And then the run is looking at the x's. You went from 2 to 5, which means you went up 3. So if your rise is 6 and your run is 3, that means your slope is 2, right? When you compare them. All right, so what have I got? I know it's going to be y equals 2x plus blah. I don't know, right? Could do that same trick like we did. Just I know the slope is 2, but I don't know what the y-intercept is. You can pick either point you want and plug it into here and figure out what the b is to make it happen, right? Let's just pick this one just because it's easier. Right, less negatives. So what this is saying is when you plug 5 in for x, you better get 1 out for y. So if I plug 5 in for x, I need 1 out for y, right? But 5 times 2 is 10. What number would you have to add to 10 to get to 1? You could subtract off 10 to see it, but b would basically have to be -9, right? 1 minus 10. So what that's saying is you have y equals 2x, and then the b is -9. So we picked this one. That's it. We're done. But it couldn't hurt to check this one, right? So when you plug 2 in, you better get -5 out for y. So plug in 2. 2 times 2 is 4. 4 minus 9, sure enough, -5. All right, what about D here? How about a horizontal line going through the point 7, 2? Well, again, remember the two things we need are slope and the y-intercept. Did they straight up tell me the slope? No. Did they straight up tell me the y-intercept? No. We got to figure it out. But wait a minute, what does the horizontal line mean? Horizontal, remember if you're going up, it's a positive slope. If you're going down, it's a negative slope. So if you're perfectly flat, which is what we want here, that means your slope has to be 0, right? You're not going up, you're not going down. So the slope can't be positive, can't be negative. It's got to be 0. Okay, so I know you can do the same thing. I know it's y equals 0x plus b. Okay, you could do the same trick when x is 7. You better get 2 out for y, right? So 0 times 7 plus b better give me 2, right? Well, that's a 0. So basically, b's got to be 2. So you're looking at y equals 0x plus 2, which you could leave like that. But the point here is no matter what x is, 0 times x is going to be 0. Plus 2 is just 2, right? Y equals 2. So you could simplify to that. But kind of the idea what you could have done, if you just think about it graphically, so like the point 7, 1, 2, 3, 4, 5, 6, 7, 2. That's this point right here, right? And a horizontal line would look like this, right? Right? Because it's perfectly flat, right? It's not positive, it's not going up, it's not negative, it's not going down, it's perfectly flat. Slope is 0. But look at it. Where does it hit? Oh, look, if you went straight across like that, if this y coordinate is 2, I went all the way over to here, to the y-axis, that's one would also be 2, right? Or you could think of as what do all these points have in common, right? Whether you went to the right, you gotta go up 2, right farther up 2, right farther up 2, left up 2, left up 2. All of them have a y coordinate of 2. Okay. Last thing here. No. Okay. Real quick, let me go back. Remember when we started this, right? It was this was what was given to us. This is what we did before. These are easy to see that the slope is the same, right? It's easy to see that you're going up by 2 because see, look, 1, 2, 3, 4, all the x's are there. There's no gaps. When x is 1, when x is 2, when x is 3, when x is 4. There's no gaps here. It's easy to see what you're going up by here. But what if your points were all over the place? You see that? See what I'm saying? So it's like 2 is this. What is 3? I don't know. What is 4? I don't know. But I know 5 is this. I don't know 6. I don't know 7. I don't know 8. But I know what 9 is. What is 10? I don't know. But I know what 11 is. See that? So it's jumping. So when it starts jumping around like that, it's a little bit harder to see whether or not this forms a line or not. Okay. This is where you're going to have to do a little bit more work, right? Because see, look, from 7 to 19, right? That's like your rise, right? If I went from 7 to 19, that would be up, right? Like 19 minus 7, right? So you're going up 12. But from 19 to 35, maybe you just calculate if you want. So 35 minus 19, right? So you're going up 16. From 43 to 35, you went up 8, right? So your rises are all over the place, right? Like before, it's easy to see. Oh, look, they're all 2, okay? But here, they're all over the place. But so are these. Because check this out. From 2 to 5 is up 3. From 5 to 9 is 4. From 9 to 11 is 2, okay? But remember, what is slope? Slope is really the rise divided by the run. The rise divided by the run. The rise divided by the run. But what is 12 divided by 3? 4. What is 16 divided by 4? 4. What's 8 divided by 2? 4. So the rises and the runs might all be different, but when you divide them, oh, look, you do indeed get the same number. Okay, so again, it's that same slope over and over again. That's what's telling you that it's a line, right? So since you have the same slope, it is indeed the line. So if I'm looking for the equation, again, it's going to be y equals 4x plus blah. Okay. And now we just don't got to figure out what the b is. Pick any point you want. I don't know why we just pick the first one, 2, 7. If you plug 2 in for x, you're trying to figure out what would this number have to be to get 7 out for y, right? But 7 would have to equal 8 plus b. Subtract off the 8, or just think 8 minus 1 will give me 7. So b's got to be negative 1. So we're looking at y equals 4x minus 1. That's your equation, right? And heck, it couldn't hurt to check, right? 4x minus 1. Because you look, 2 times 4 minus 1. Sure enough, there's your 7. If you did the same thing, but you still plugged in 5, see, it's giving you, oh no, it's 4. What am I doing? 4 times 2 minus 1, right? 7. And then the next one, when you plugged it in, I want to plug in 5. So now, right, I'm plugging into 4 times x minus 1. So 4 times 5 minus 1, sure enough, there's your 19. If you went and plugged in 9 for x, sure enough, there's your 35. And you could even plug in the 11. It gives you 43. It's working, right? All right, so what's the punchline to all this? What makes a line a line? Same slope. How do you find the equation of a line? Figure out the slope, figure out the y-intercept, plug them in. There you go.